Okay, before we come to the analysis of the DLG file, let's look at our initial work again. You may want to now use the other options to get the active site. So in which case, we'll delete this site sphere. So we can use PDP site records as long as you have internet connection. That should work. Okay, so you see this is slightly bigger active site AC1, and you can also select this like we did before. You highlight this and then see the attributes. So you see that this is slightly different from what we had earlier, and you may also see the impact directly when you are using an AutoDock to set grid. So we may want to just test that here before we move on. Here, this is the first one, 89, AutoDock, grid box, Control V. Then the next one, we come back again here. The final one. So for us to get a better view, let's take this one back to 0.35 and then apply. So you can see this one actually naturally covered the active site on its own. So you may wish to work like this directly. Because looking around, you see that the itaclinic acid is not showing around the whole area. You could also still increase this to 0.5 just to increase the area. So that's about that. And then from here, go ahead to save as we did before and continue your work. Now that we have a DLG file, that's the docking log file, we can clear this from, okay, clear. So to analyze our results, we can now come here, dockings, open, the DLG file, open, okay, 50 docs confirmations because we set it to 50 runs. Then back again to analyze, macromolecule, choose. Okay, I have to go bring it back in because I already deleted it. Macromolecule, I'll use open instead. So that is the macromolecule there. And then conformations, play. So this second button here, you click, create some space, and then you say show info. So it will show you information about each of the binding poses. So this is binding pose 1, like you can see from here, and this is all about it. We can now go on to show build hydrogen bonds if there are any. So if there is, it will build the bond, and then you can now write the complex also. But we need to know, because if you're writing all the 50, it's always determined by your research anyway. In this case, I want to write the binding pose with the lowest binding energy. So we'll go back to our DLG file, then just Control F, RMSD, enter. So you see here the clustering histogram. So there were 6 clusters, and round number 28 had the lowest binding energy, minus 10.16. The mean for this cluster, and in this cluster 1, there were 16 conforming binding poses. Then you see that for number 2, number 3. So our interest now is round number 28. So we'll come back to AutoDock. We go to 28. Okay, see, it will build hydrogen bonds in a case where there is a hydrogen bond. Otherwise, it will just ignore and continue its work. So we're currently at 7 now. Or we could just stop and then use this to fast track it. We're going to 28. Oh, come on, my bad. So binding pose 28. This information is not correct. We'll go through that again. Now we've got the accurate value, 10.16. You compare that with what you have in the drive, minus 10.16. So now we have the right value, and there's one hydrogen bond at arginine 45. So we now want to write this complex and save it, best binding complex. So if you write all, it will write all the 50. We're interested in just one, write complex. So we can call this one now our docked complex. And it's better to save it as PDBQT because converting to PDB here may mean it works though, you just type .pdb, but let's leave it as PDBQT. Come back to your working directory to confirm docked complex. Okay, that's it here. Okay, sorry, we did not I'll just edit it from here. .pdbqt. Okay. Now for conformational validation, I will first close this session to clear the screen. Then I will bring in the docked complex. I also want to separate the ligand from the receptor. Yeah, there we have it. Like we did before, we'll come to select residue standard amino acids. That leaves us with the docked EAA. That's the itaclinic acid. Then we can go to actions, atom bonds, delete. Okay, then let's go back and see if there's another thing that is standing by EAA. Okay, if that will not work, then we'll do it manually. Control Z, edit to undo. So we'll click this. So after cleaning the protein, we have these ions hanging around. We don't want them here. So let's try to get the names. This is okay, Cl1. So we'll come to select structure. Let's get ions. Fine, we've gotten the ions already. Then we can go through the other process, atom bonds, delete. So they are out. So what we now have is the docked configuration. We can save this now as let's save this as docked ligand. Save. Recall we already had the docked the co-crystallized ligand. So for the first validation, let's now go over to PyMOL. Like we did before in the command line here, cd, change directory to our working directory. That's already done. Then from here we can open. Or you could just go directly drag the objects into this place. So this is the docked ligand. We had the itacrinic acid in mode 2. Let's use the PDBQT also. And then we had the clean protein. So they will all be uploaded now as 3 objects. So we can just scroll up to show more detail. Now let's try to get it into proper perspective. So we have these 2 complexes. One of them, this is the docked, and this is the one that came originally. So you can click to hide and click to review. Let's make it easy for us to detect. Let's color this one cyan. Oh no, that's the same color with the, let's color it red instead. Then we color the other one, say yellow. So now it's easy for us to look at the 2 of them. So we have this and we have this. We want to check the if our docking was close to, if it's between 0 and 2 angstrom, then we are good. So we'll just say align. The names here we have itacrinic acid. It is itacrinic underscore acid, comma, and then we have the other one as loaded as what? Docked ligand. No, docked ligand, please. Enter. Oh, something is wrong there. Invalid selection name itacrinic acid. So we didn't do that one correctly. Okay, we'll go over it again. Oh, I can see the error here already. I typed in the wrong. What itacrinic acid I typed was incorrect. So I'll just call that one back up and try to itacrinic arrow before Y. And then we'll keep this here and then we'll run. Good. So once the spellings are correct, everything is done. 17 atoms were matched, and then we have an RMSD of 1.687. So this is good enough for this particular docking. So in summary, for the series we have seen so far, it is from cleaning with protein, ligand. Like I said, you may be working with ligands from a public database like PubChem, Zinc, and other databases holding established or already identified compounds. So in your own case, you may not be working with the same, but I have done this just to prove that yes, the docking procedure is correct. If the RMSD was greater than 2, or as from 3 and above, it becomes unacceptable, even though sometimes some people report that around 3 is fair. So that is it so far. Now we have docked. We now know how to do a flexible ligand rigid receptor docking, and how to calculate or analyze the results with AutoDock, and then how to calculate the validation. So if I were, for example, interested in other compounds, I will do this to confirm the docking process and then use this same protocol to dock the other compounds that are of interest.